In lesson 4, we are going to look at a specific type of recursion formula, which is called Pascal's triangle. So Pascal's triangle is a pattern that we use quite a bit, and the way it works is that you'll notice that there's always 1 on the outside of the triangle. So all the ends start with a 1. Let's just erase that, we don't need that now. And then the terms in between are determined by adding the two terms together. So we start with 1, we have 1 on the outside. If we add 1 and 2, we get 3. If we add 1 and 2, we get 3. So we start the next row with 1. We add 1 and 3 to get 4. We add 3 and 3 to get 6. We add 3 and 1, that should be a 4. And then 1. If I wanted to do the next row, I'd start with 1. 1 and 4 make 5, 4 and 6 make 10, 6 and 4 add to 10, 4 and 1 add to 5, and 1. So that could be continued forever. So how is this useful? Well, Pascal's triangle is useful when we are expanding binomials. So a binomial, remember, has two terms, and this is called the binomial theorem. And you probably see this more in data management. So if you're going to take grade 12 data management, you would see this used quite extensively in that. But we're just going to use it simply by expanding binomials. So if you think of x plus y to the power 3, if I wanted to expand that, it would mean x plus y times x plus y times x plus y. And that can be quite time consuming to do that expanding and collecting like terms. So what we can use is Pascal's triangle to help us expand this binomial. So how does that work? So the pattern is the x variables are going to start with the lowest number being 0, and the y variable will start with the highest number being 3 because it's power 3. So x starts at 0, y starts at 3. X is going to go up 1, so 0 goes to 1, and y is going to go down 1, so 3 goes to 2. X is going to go up 1 to 2, y is going to go down 1 to 1, x is going to go up 1 to 3, y is going to go down 1 to 0. So let's recap this. X starts at 0 and goes up. So 0, 1, 2, 3. Y starts at the highest power being 3 and goes down. 3, 2, 1, 0. Where does Pascal's triangle come in? Well, it gives us the coefficients of this binomial expanded. So since it's power 3, I want row 3. In the triangle, this is row 0, the top. The next row is row 1. The next row is row 2. The next row is row 3. That's the row I want. So the coefficients are going to be 1, 3, 3, and 1. You'll know if you have the right row because the number of coefficients have to match the number of terms that you have. So if you have too few or too many, you know you're in the wrong row. And then we're just going to tidy it up a bit. I don't need the 1. I don't need x to the power 0 because that's just 1. So we'll write y to the power 3. We don't need the 1 on the x. We'll just put x, y to the power 2. And then 3x, 2, y to the 1. We don't really need the 1. And then in the last term, we don't need the 1. We've got the x to the 3, and we don't really need the y to the 0. So this is expanded, nice and tidy and cleaned up. So let's try it with x plus y to the power of 5. I need a bit of room here. So x will start with 0, y will be the highest power, which is 5. X is going to go up, y is going to go down. X is going to go up, y is going to go down. X is going to go up, y is going to go down. X is going to go up, y is going down. And finally, x goes up and y goes down. So let's double check. X goes 0, 1, 2, 3, 4, 5. Y goes 5, 4, 3, 2, 1, 0. And then we'll put in the coefficients. So it's power 5, so we want row 5, which is this row. So 1, 5, 10, 10, 5, 1 are going to be our coefficients. 1, 5, 10, 10, 5, 1. And then we'll just tidy it up. Y5 plus 5xy4. And we'll just clean up these terms. And there we have it. Now we can also use the binomial theorem without just using x plus y. Perhaps it's maybe 2x plus 1 to the power 4. So my suggestion, you don't have to, but my suggestion would be x plus y to the power 4 first, and then we'll replace x and y with 2x and 1. So x would get replaced with 2x and y would get replaced with 1. So let's do x plus y to the power 4. We want the fourth row. So the coefficients are going to be 1, 4, 6, 6, 4, 1. So it's going to be 1. X0, Y4. It's going to be 4. X, Y3. It's going to be 6. X2, Y2. It's going to be 4. X3, Y. And it's going to be 1. X4, Y0. So let's double check. X is 0, 1, 2, 3, 4. Y is 4, 3, 2, 1, 0. Coefficients are 1, 4, 6, 4, 1. Then I'm going to replace. So let's just keep in mind here, we have no x there and we have no y there. Oops. So I want 2x plus 1 to the power 4. So x is going to be replaced by 2x. Well, in the first term there is no x. So y is going to be replaced by 1. In the next term we have a 4. X will be replaced by 2x. Y will be replaced by 1. In the next term we have a 6. X will be replaced by 2x. Don't forget that's squared. Y is replaced by 1. In the next term we have 4. X gets replaced by 2x. That is power 3. Y is replaced by 1, and then in the last term 2x is replaced by 4. So 1 to the power 4 is 1. In this term I have 1 to the power 3 is just 1, so I have 4 times 2x is 8x. In the next term I have 2x to the power 2. So 2 to the power 2 is 4, times 6 is 24, the 1 squared is just 1, and then I have x squared. In the next term I have 2 to the power 3, which is 8. 8 times 4 is 32. X to the power 3. So don't forget the variable is also has the power applied to it. And in the last term I have 2 to the power 4, which is 16. X to the power 4. And then I'm going to put it in descending order. So I'll put x to the power 4 first. 32x to the power 3 next. Then the square. Then the 8x, and then the 1.